Geek Wisdom.
Disclaimer: the views and opinions expressed in this article are those of the authors and do not necessarily reflect the opinions of my employer. Examples of NS code used in this presentation are only examples. They should not be utilized in the real world products, as they should be considered as based on limited and possibly dated open source information. Assumptions made within this presentation are not reflective of the position of any private or government entity to which the author is presently employed.
Recall that from episode 1 of the history of the Internet, that the Internet is a collection of protocols. These protocols were developed by researchers, mostly at universities, and we sent out the details in what were called RFCs, Request for Comments. Now different groups got together and would produce different client software and server software based on the details in these RFCs. Now although this allowed users to communicate via a network over great distances, things were not all perfect in our new net. Because different implementations meant lots of different developers were creating different ways of implementing those RFCs. And they left them open to various security holes. Once an exploit was known for a given server implementation, then that could easily be exploited to all servers all over the Internet. Now this was also during a time when people were connecting via old-fashioned modems, and it used up their phone line while they were connected, so nobody else could call them or talk to them. So many client software would develop the ability to go into a work offline mode. You could download your email or download different newsgroup messages, read them while not connected, even respond without an active connection. Then you would connect later and submit your messages and download new ones to read more. Now the original World Wide Web, which was the later of the protocols, also had some offline capabilities, but not a lot. It pretty much required that the user be connected all the time to view all the pages and read information using up both internet time and the phone line. Now around 1997, David Weiner designed and implemented a syndication method for web pages using XML. This was sort of the precursor to what we've known as blogging. And it was called RSS, Really Simple Syndication. It would actually allow you to store selected content from different online web blogs for later reading. You could subscribe to that page, and as the data on that page changed and new articles were written, it could automatically download and keep you in an offline method. Over the next year, Mr. Weiner continued to work on something called XML RPC. This was a method of doing remote procedure calls over the World Wide Web by passing a message to the server in XML format. This would allow users to prepare content for their personal journals or web blogs while offline and then post the content when they were next online. One of the first known logs of this kind was called Robot Wisdom by Jorn Barger. He's really the guy who's coined with inventing the term blog. Welcome to today's presentation, Web Services 201. Now the reason I call this a 201 course is because it has some prerequisites. To fully appreciate the content being provided in this presentation, it's important to familiarize yourself with a few concepts, such as the client-server model, the principles of component-based architecture, and have a good introduction to how Internet programming works and sockets. Now, if you're not familiar with these concepts, I suggest you check out my two earlier videos, Internet Programming 101, which will give you an introduction to Internet programming, the initial history of the Internet from a programming perspective, and then look at the component-based architecture. And these are two videos, parts 1 and 2, which will talk in further depth about the principles of using components, which will be very important as we talk about web services. So the agenda that we're going to talk about today, we're going to describe what is a web service, give some definitions. We're going to talk about some key concepts and terminology around web services and what they mean. We're going to do some examples where we walk through how to build a web service and how to consume a web service. And we're going to look a little bit about what I call the secret man behind the curtain, how it all works. Fast forward to today, we see that most people have internet connections that are constantly online. We don't use our phone line and tie it up at the same time. Most of these offline clients have now been replaced. Just think your email is now in your web browser, and your IRC and your chatting have been replaced by social networking sites like Twitter or Facebook. And as time has elapsed, all of those old TCP/IP protocols like your Gopher, Usenet, have all been destroyed. We owe this destruction in a large part to the web service. So what is a web service? Well, the W3C, the World Wide Web Consortium, says it's a software system designed to support interoperable machine-to-machine interaction over a network. If you recall from Internet Programming 101, we do this via sockets. One particular implementation is the web server, which happens over port 80. Now, many years ago, in a land far, far away, we've seen this before. We created things called application programmer interfaces, way to call an application from another application. And the DCOM invented by Microsoft is the Distributed Component Object Model. We have plugins which allow people to write programs which interact with a main program. We spoke about remote procedure calls, the idea of calling a system from one spot in the network to another spot. The ability to call and access one application from within another application could be locally, like with a dynamic DLL, or remotely. Now, these are all unstandardized methods. We have the RFCs, but the implementations of those RFCs could open up different security holes. But what I'm really getting at is web services are just the same old thing as we've seen before, just done in a new way. Now we're exposing these services over the HTTP protocol. Remember, there's nothing new in computer science or information technology. Okay, let's look at some key concepts around web services. We have the idea of an endpoint. This is the server that receives the request to do something. So if your endpoint is at server name / reservation service, then your service is called reservation service. Method, or sometimes known as operation. This is sort of the function that the web service provides. So you could have a method called make reservation being provided by the reservation service. WSDL. This is the Web Services Description Language. This is a machine language that a client can use to understand how a web service works, and it forms part of the SOAP standard, the Simple Object Access Protocol. We'll talk about that a little more later. Now, the endpoint is what's offering the service. It's producing the service. It's exposing something as a service. Another application, it could be an application on the web, it could be a console application, it could be a Windows application, it could be written in Visual Studio, .NET, it could be written in Java. It's consuming the service. Generally, the service offered and consumed are performed over the existing hypertext transfer protocol. It doesn't have to be, but generally that's the way it works when we call it a web service. It's using the hypertext transfer protocol. So we're basically adding on top of the layer of that protocol another protocol for web services. Now, SOAP and its original predecessor, XMLRPC, are technology independent. An application written in Java can consume a web service written in .NET. Or a web service written in Java can be consumed by a client written in .NET, or any language for that matter. The agreed specifications of what the web service does, how it can be accessed, and where it is called a web service contract. So WSDL is an example of a web service contract. Now the two methods are SOAP and REST. REST, which stands for Representational State Transfer, is a style of calling web services, which means you're calling the method directly from the URI using the main methods of what HTTP provides: get, post, put. It's a more lightweight way of calling a web service than to use the SOAP, which is an XML-based protocol. So SOAP is a standard, REST is an architectural style. Now, today's examples, we're going to use several different languages. Some demonstrations will use the existing web server we created in Internet Programming 101 that was written in the C language. We know that that program can call other programs which could have also been written in C or in Bash or really in any kind of executable form. We'll show examples of calling a web service, for example, in JavaScript, and we'll show some examples in C#, and we'll show some further examples in Visual Basic.NET. And for some examples, we will be using the Visual Studio IDE. We'll use Visual Studio 2013 Community Edition, and we'll be using an IIS web server to host some of our web services as well. Okay, so enough with all this history nonsense. Let's get into looking at a real web service. So if you followed our Internet Programming 101 learning material, you'll remember that we created a simple web server. We called that web server Listing 6. So it's still there, and I'm going to compile it. I'm not going to go into the details with how it works. You can go read or watch the video Internet Programming 101 to understand that. But it's going to create this a.out file. And what you can remember from our Listing 6 is that it has two parts. It can both serve HTML files, and if it's an executable file, it can execute that file and return the result. So we do have a file to serve called helloworld.html. And I'm going to show you what that file looks like. So inside the HTML markup, we have a basic title web service demo. We're going to have a little prompt, what is your name? We have a little text box you can see here where they're going to enter the name, and when they click the button called say hello, it's going to call this JavaScript function called say hello. So if we scroll down a little further, we'll see the function say hello. Now, when we want to call other web pages from within our JavaScript, we use the component of JavaScript called XML HTTP request. So I initialize a new XML HTTP request, and then I need to set the data that I'm going to send to it. So the result element called ID result is going to get stored in this variable called result. Then I need to set up an event handler. So an event handler, once I make the request to the server to read the data from the web service, I need to wait for the data to come back. So that's what this onReady state change is. So when the data comes back, the ready state is going to become 4, meaning I've successfully loaded the page. And if the data that came back was successful, we know from our learning of internet programming that it should return the message 200 OK. So that request.status will store that 200, and then we know it was a successful get request. And then we're going to set the result div to whatever that request came back with. Response.text becomes text content. If something goes wrong, we're going to show that an error occurred, and we're going to output the details of what that error was, which is stored in the request.status component. So note in this piece of code here, nothing is actually getting called. I'm defining a function that's going to run when the ready state changes. And then down below it, I'm going to get that name that the user typed in, and I'm going to send a GET request to the HTTP server. So if you remember our interpreter pattern, HTTP requires a message called GET, and I'm going to request the file hello text, and I'm going to pass in the name. So that implies that on our server, we have a program called hello text that takes in a name and does some sort of output. So let me show you that. So I created a program called hello text.c. There's nothing special about it at all. It just has a main program, and whatever it takes in is that first argument. It's going to put hello, and then it's going to replace that with the first argument. So if I compile that, I can then run hello text, pass in a parameter such as Brad, and I simply get back the text hello Brad. So remember, our web server is capable of recognizing that as an executable file, and instead of just displaying the contents of that file, it's going to execute it, passing that same parameter, and then the output is going to feed back into that JavaScript function. So let's see this work. First, I'm going to start up the server so that it's listening for connections. Again, if you want to see how this works, I recommend Internet Programming 101. Then I'm going to go in my browser and go to that web server. And remember that I run it on 8888. So you can see now it's gone out, found that file, read the hello word HTML, sent it back to my browser, and now it displays on my screen. I have that prompt, so I can type in what is your name. Now when I hit this button, it's going to call that HTTP request object, which is going to make another call to the web server, which is going to call that hello text executable and return the result. And then it's going to display in that invisible div right under the screen. So when I hit say hello, it went out to the server, got the request, ran the hello text program, returned the result, and stored it in the div. And if we go back to the server, we can see it received a file name hello text, the argument as Brad. It then read that hello text program, which returned hello Brad, and returned it back. Now, the file format that we're passing back and forth in this case wasn't HTML, it wasn't XML, it wasn't a SOAP message, it was just plain text, but nonetheless, this demonstrates a basic web service. It's closer to what we would call a REST web service, representative state transfer, because we're using the underlying components of the web, that GET method, to retrieve the results. We're not passing anything special. We're not executing anything over and above. We have no XML that we're processing. So it's basically a simple GET request. If you'd like to learn more about how JavaScript does this, you can look at the JavaScript 101 video, or you can do some searching on tutorials for what's called AJAX, which is the ability for JavaScript to make calls back to the server dynamically while your page is running. Now let's take a moment and review. The user typed a page in the web browser, helloworld.html. The web server retrieved that request for that file, found that it existed, and then sent it back to the browser so that we could view it. Then the user enters their name in the box and clicks the button, say hello. The JavaScript instantiates a component called XML HTTP request object and sets it up so that when the data comes back, it can store it in the proper frame within the div. Then executes the GET request that would be used just like the web browser could do, to say, go give me this file, hello text, and it's going to pass in whatever the user typed as their name. The server runs an interpreter pattern which interprets the GET request and executes the hello text file and returns the results back to the user's web browser. So using our terminology, in this case our endpoint was http://localhost on port 8888 hello txt. The service that we consumed was called hello txt. There was no actual method that we called here. We could have added a method, but in this case we just used a service and called it directly. The execution that we did relied on the native HTTP, mainly that GET command that is part of the HTTP protocol. And we didn't send any special XML or SOAP messages. We just passed plain text back and forth. We used that GET request based on the native HTTP, and we would call this REST style, Representative State Transfer. Now, those of you who are familiar with REST might say this isn't exactly REST. REST is considered an architectural style. It has certain guidelines to follow, but it's not strict as a particular standard might be, so it's close enough. And it's definitely closer to a REST style we've done here than to a SOAP style, which we will see later on. Now just recall, I started this web server from within a command line interpreter, the bash interpreter. That is executing a program that I compiled, which is our web server, listing c6.c. That web server is then running an interpreter pattern, which is looking for something to do. It finds the hello text file and executes it, and this cycle continues. So we're basically building layers upon layers upon layers. This is a protocol on top of a protocol. Why not use a web service? Why not just use straight TCP/IP? Well, as I mentioned earlier, all of these different TCP/IP ports being open on the internet represents a security risk, because all the different servers implemented things differently. Some people might have different security holes. So by locking everything down, you're narrowing the amount of ports that are being used. So for example, if you're a server in Harvard, you can't talk directly to a database over the protocol, let's say for the Oracle database, to the server that might be in University of New Brunswick. Those are locked down with firewalls. However, both of them, you can be confident will be open both for their web servers on port 80 and the secure version on port 443. Does that really make it more secure? Well, there could still be exploits to those programs that are providing those services. But at least you know there's no firewall restrictions and there's less ability to exploit because the web servers are running pretty much common standard software. Now there's arguments to be made that said, well, web services are technology independent. As I said before, a client could be written in Java to consume service written in .NET or vice versa. But so is TCP/IP. If I have a simple mail transfer protocol, that's a standard protocol that can be implemented in multiple languages. In fact, there are multiple different browsers, Internet Explorer, Firefox, Google Chrome, all which are implemented in many different languages, but provide the same result, and as long as they're using the HTTP protocol, work the exact same way. The smart ones out there might be saying, but this must add a lot of extra overhead. Well, yes, it does. Web services, as I said, are a protocol on top of an existing protocol. And if you're using XML to pass the data, for example, in a SOAP-based system, now you've added additional XML. So your package of information in addition to your raw data is now wrapped in XML, making it even larger. If I were to contact a database service directly, I might expect to receive a response in, 5 milliseconds. But by adding this extra overhead, now it might take 500 milliseconds or even 900 milliseconds. Now you might think from a typical user experience, they're not really going to notice much difference. But they certainly can if large volumes of information are being passed and forth or a large amount of transactions are occurring. So we get around this. We solve this problem the way we've solved it for years and years with other systems. We use read caching. So data coming in isn't going to change very often. So if I call the web service once, probably within the next minute, if I called it 100 more times, I'm going to get the same information back for the same request. So if the first time I receive it, I store that data somewhere, then everything else that calls it, I can keep sending them that cached information. It could be cached in memory, it could be cached on my local disk, so that I don't have to make the more expensive call each time to the web service, until of course that cache expires, and then I go out again. Now we talked a little bit about REST, so let's take a few minutes and talk about SOAP. And no, I don't just mean the product that you use for personal hygiene to wash your hands and your face. Before we get into SOAP, let's remind ourselves about XML-RPC, something invented by Dave Weiner and dates back into the history of blogging. This idea of sending XML data over the web to execute a procedure remotely. So we've seen remote procedure calls before.
in Internet Programming 101, and then we talked about the components-based architecture. The only difference now is the data that we're passing back and forth is an XML message to execute that remote procedure. So here would be an example of an XML remote procedure call. We have the XML request. We say, I would like to please call the hotel reservation service. And we're sending this data to that endpoint. The method name is called make reservation. We're going to send over a reservation line. And the values of that line is going to have a check-in date, a check-out date, and the reservation name. So the problem with this is there's multiple different ways that I could have structured that XML. It's not standardized. So SOAP helps us standardize that in a common way. Basically, it wraps it in an envelope that looks like this. So we have, and if you've seen HTML markup, you know how your HTML has the HTML, and then it'll have a header tag and then a body tag. The SOAP envelope works the same way. You start and wrap it into an envelope called a SOAP envelope. Inside you can have a header that might have information for authentication or additional information about the SOAP message. Then you have your main body, so that's where your XML specific code is going to go inside that body. SOAP also defines an ability to pass error messages back and forth. So if something goes wrong in the calling of the method, it gets stored in a part called a SOAP fault. So it's optional. It's only going to be in the message if there is an error going back and forth. And then you're going to end your body, and then you're going to end your envelope. So you can think of that like HTML. You have your start HTML tag, your end HTML tag, your body tag, your end body tag, and then your message is inside. Now SOAP itself, if you're familiar with service-oriented architecture, we said that's when an enterprise comes together and starts to think about how they provide services and how they can write their code and their components in a way to provide services and expose those services to end users to use. So it might be worth thinking that SOA is service-oriented architecture protocol, but it really isn't. In this case, it stands for Simple Object Access Protocol, because we have an object, in this case a reservation request, that we're trying to make, and we need to simply access that object, or in this case, send information to create a reservation for that object. Too simple. We use SOA meaning two different things just to confuse others. And it standardizes the way the XML message looks. So if we took our original XML RPC for make reservation and we wrapped it in a SOAP envelope, it would look like this. Again, we have that XML tag. We have our XML envelope being defined. Now you see in our body, we have this make reservation request. We have a method called make reservation. We have a reservation line, again with our check-in date, our check-out date, and our reservation name. And now we have a standard way so that if I'm a Excite or a Travelocity, that I can make reservations in multiple hotels by passing the same message wrapped in the same standardized envelope. So let's look at some examples now. Building a SOAP message using VB.NET, building a web service using SOAP, Visual Studio, and IIS Web Server.
Okay, so in this video, we're going to look at creating a web service in Visual Basic.NET. We're going to do it using the Microsoft Visual Studio Community Edition 2013. So this is our first experience using an IDE, Integrated Development Environment. Visual Studio Community 2013 is a free one that you can download from Microsoft that is basically a full-featured Visual Studio IDE, just like Visual Studio Professional. It's licensed for a single user to use as much as they want, whether for commercial or non-commercial purposes, but it can't be used by large businesses. So it's a good tool to get you started with Visual Studio and getting you started with the IDE. Now you can use a later version of Visual Studio. I'm using Visual Studio 2013. Don't use one earlier, because as we'll see, Visual Studio 2013 and above give you the ability to change the version of .NET. Today we're going to be building a web service in ASMX format, which is an earlier version of web services for .NET 2 and .NET 3.5, and we're trying to build one using that format. So I'm going to go File, New Project. I'm going to present it with what type of project do I want to build. Now we'll notice in here, if I did a search for the word service, I will not see the ASMX format, because it doesn't exist in .NET 4.5. I can, however, switch to .NET 2, and I will see an ASP.NET Web Service application. So that's the one that I'm going to choose today. And I'm going to call it Hotel Reservation Service. And I'm going to put it in my training directory, Hotel Reservation Service. Now, what's going to happen is Visual Studio is going to open that up. It's going to build sort of a sample web service stub for me. So no matter what you called your web service, you're going to get these same set of files that are going to show up in your Solution Explorer. Okay, so what we see now is our solution over here called Hotel Reservation Service. And it sort of started with this main service1.asmx. So that's going to be where our main web service is stored. So what I'm going to do, the very first thing I'm going to do is I'm going to rename that to something that makes more sense. So I want it to be called Hotel Reservation Service. The next thing you're going to see is up top here in your code, you have this line that says Web Services Namespace. Now you can use anything you want for your namespace. It doesn't have to be a valid address. It can't be tempuri.org just because .NET does a check to make sure that you have at least changed it to something else. So I'm going to call it the Travel Management System.org, and let's call it Hotel Reservation Interface. So some of the things that automatically get added, these little quotes, these little brackets, okay, they're basically modifiers to your class. So my class here is called Service1. I don't really want to call it Service1. I want to call it the Hotel Reservation Interface. And so these modifiers are saying that I have a namespace for my web service, and then I'm going to create a binding that conforms to basically SOAP is what that's telling me, because this is going to be a SOAP-based web service. So this is just basically a class like you've seen in any other Visual Basic program. There's nothing particularly special about it except that I'm going to be inheriting the web service property so that it has all the same properties as any .NET web service would. And then similarly inside the class you create methods which actually do the stuff that you want your object to do. In this case I'm putting the web method qualifier above it so that .NET knows, okay, this is going to be a method that would be exposed. I could have other public functions or other private functions within my class. If I don't have that web method in front of it, then it's not going to be exposed. So from a web service point of view, it's not going to be something that I can access. I could still use it as a DLL and access it from other applications as a component, but without that web method, it's not going to get exposed. That's how you're telling .NET this is something we want to expose. So our basic program came with a little hello world, not really what I'm looking for. So I'm going to call this the name of my service, which is called Make Reservation. And it's going to take in a reservation line. And in my case, I'm not really going to be returning anything in my function. I'm just going to return an empty string for now. Now the other thing that's very important, I renamed this ASMX file to Hotel Reservation Service.asmx. If we look at its markup inside, we'll see that even though I renamed it, it still calls it Hotel Reservation Service.service1 here. I have to remember to change that so that it also calls it the same class name that I gave it here, Hotel Reservation Interface. In fact, I should be able to just copy that and paste it right in here. So that's how it knows which object is going to instantiate when it wants to call the web service. So they have to say the same thing. Okay, so now I basically have an empty method that really isn't doing anything. So what I'm going to do is I'm going to use an existing component to actually process that reservation. So I'm just going to show you that there's add a reference here to an existing component that I have. Add reference. and it's called reservation request.dll. Now that was built in our earlier version. If you're interested in seeing what reservation request.dll is, I would recommend you check out Introduction to Component Architecture 101, and we sort of build those DLLs. I'm going to check that reservation request. Then of course I need to import the namespace that uses. That is my travel management system namespace. And if I want to use it, let's dim my reservation request as hotel reservation as new. That should be as new equals new hotel reservation request. And then let's call it by going req. It has a method called make reservation. Now it takes in that same reservation line. And our second parameter has to be some sort of database that I'm storing the reservations in. So it's just a plain text file. So I'm going to hard code that to training. Oh, let's put it there, reservations.txt. So that's going to be the database that stores our reservations. Just to show you, there's already a file there from previous testing. And if I show you what's in that, you can see that it has a couple of sample reservations that were made for a couple of days, and then it's a room number, a check-in date, a checkout date, and then the person whose name the reservation is under. So nothing too special. So we've exposed a web service called Make Reservation that's going to take in that reservation line, that check-in date, that checkout date, that reservation name, and it's going to call our existing component, which we could use in other applications to make reservations and update the reservation database. So now I'm going to build that solution. We're going to look down here, see it being successfully built. Oh, so what you've seen has happened here is my reservation component was written in .NET 2, and I'm trying to use a .NET 4 object. So one of the nice things about ASMX files, although you can't create them with .NET 4, they are perfectly fine to upgrade to .NET 4. So to do that, I'm going to go into my project, and I'm going to upgrade it from that .NET 2 that we originally picked to the .NET Framework 4. And it's going to give me a warning saying you have to close and reopen your solution for this to work. No big deal. It's going to close it, reopen it in .NET 4.5. Now I'm going to build it again. And we see that it's successfully built without any errors using the .NET 4 reference, and it's a .NET 4 service, .NET 4.5 actually. So now we have it built. How do we actually deploy it? So an ASMX file must be deployed to an existing Internet Information Services server. So we're going to do this very similar to the way we would deploy any web application. I'm going to show you the files that were built. In here you see we have the ASMX file, that's sort of the main service, the web.config that runs it. And in our bin directory, we'll see that we have the hotel reservation service, that's the main program that's going to run. We also have the reservation request DLL, and that's the component that actually does the reservation details. So what we're going to do is we're going to take those, this one, our web.config, and our bin folder, and we're going to copy those into our web server, which we have running at netpub www. Now this could be, you could have this configured wherever you want. This is just a default web server. Paste them in there. Okay, and now we have our web service running on our web server. And we can test that just to show you what it looks like by going to, say, Google Chrome or whatever our favorite web browser is. Our web browser is running on localhost. we called it the Hotel Reservation Service.asmx. Hotel Reservation Service.asmx. Now you can see the hotel reservation interface, which has a method called make reservation, and I can click on that method, and I have a little test routine that shows how it works, and you can actually invoke it right from this page and put in a sample reservation line, and then it even shows you the SOAP messages that get passed back and forth for in both 1.1 and 1.2 to make send an actual message. Now, although we've created this web service, how do we actually use it in our application? How do we actually call it? So the way we're going to do that is we're going to build a client, and you could imagine that building of this client is being done by a different company, a different organization. So if the reservation service was being offered by, let's say, the Sheraton Hotel, now we're going to call this reservation service from our travel management system, which could be located hundreds of miles away on the network. It's going to take advantage of this service. It's going to consume this service. So to do that, we're going to create a new, and let's do this as a console-based project. So we're going to do a new console-based project in Visual Studio, and we'll do it in the right 4.5, and we will pick a console application, and we will call it our hotel request client. So this just is basically going to open up a new empty form, empty client. Now I'm always going to put at the end of my page console.readline. And the only purpose for that is so that it pauses in the output so that we can actually see what's happened. Now I want to be able to use this service. So what I need to use a SOAP web service is what's called a WSDL, Web Service Descriptor Language. And thankfully, whenever you deploy a web service using ASMX, that's automatically included for you. So if I go back to my web service, and you see this hotel reservation interface, you can actually put $WSDL, which returns the WSDL file that can then be imported into your client application. So I'm going to take that address there, and I'm going to go in here and I'm going to say I want to add a service reference. Now, I'm not going to add the service reference up here because it's done in ASMX. We do that a little differently. We're going to say advanced. We're going to say add a web reference. This is for compatibility with the older ASMX format. We're going to paste that same URL with the WSDL in there. Visual Studio is going to find that service for us. And it's going to say, okay, I found one service called Hotel Reservation Service, and it has a method called make reservation. I'm going to add that reference. Basically, it added that necessary stub code to our program so that we can call that service remotely, so that we can execute it as a remote procedure call. Now, adding a reference, whether it be a web reference or a reference to a component, basically works the same way from this point of view on, so we still need to be able to use it. We're going to import the hotel reservation client .localhost, so that's so that we can use it. In our main routine, we may want to be able to get information about the details of the reservation, the check-in date. So suppose we want to prompt the user. So let's ask some information. Dim check-in date. So here we've created a very simple routine to get the information from the console. We're going to prompt the user for a check-in date, a checkout date, and a reservation name. And we're going to build that into a string called reservation line, which is going to be our check-in date with the space, our checkout date with the space, and our reservation name. So now we've captured the data. We now actually want to make that call to that Sheraton hotel and set up the reservation. So we're going to call that web service by creating a new reservation request as localhost hotel reservation service equal to new. So again, from this point, .NET is making it look just as if we were calling a component locally or a dynamic link library. Instead, we're going to be calling it remotely over an interface, but it looks pretty much the same. I create an object, creating that sort of stub of hotel interface to use it. And now I'm going to call it res request dot make reservation, taking in the reservation line. And then maybe I'll send a message back to let them know we made the reservation. Let's build that. And now let's run it. So just as a reminder, if this is our reservation server containing that reservation database, this is who it has in it right now. We're going to add a new one. So we're going to say, okay, 2018, say the 15th. Check out on the 16th for Donald Duck. It's telling us it sent that reservation request to the hotel server. Now if we go back and we look at the server and we look at that file again, we see we successfully made the reservation at that hotel for Donald Duck. So that example is using and exposing an ASMX file and calling it as a client. Now remember that the server can be in one spot. In this case, they're all on the same machine, but the server could have been running a hotel in the Sheraton, and our client could have been a travel management system, I don't know, in Vancouver, and they're talking to one another. The user's taking the details in, and it's making the details over on that server. So we've successfully exposed our hotel reservation component as a web service, and then we had another application that was able to call it and use it successfully.